This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Welcome, listeners, to a new episode of SE Radio. My name is Johannes, and I'm sitting here with Rebecca Parsons, who is CTO at ThoughtWorks, where I coincidentally also work. Before working for ThoughtWorks, she was an assistant professor at the University of Central Florida. She earned a PhD in computer science from the Rice University. Today, she is also chair of the Agile Alliance and has over 20 years of experience in application development in industry ranging from telecommunication to emergent internet services. She has also been already on the show together with Martin Fowler on episode 182 about domain-specific languages. So welcome back to SE Radio, Rebecca.
Thank you very much.
Yeah, and you're actually the first guest we invited because some of our listeners said, I want to really hear Rebecca Parsons.
Oh,
so,
my.
That's why we picked you up. So I hope we make our listeners happy with that. Is there anything you want to add to yourself?
Well, about the only thing I would add is I have also done a significant amount of work recently with UNICEF in Uganda. I did my sabbatical there. They have a sort of informal fellows program where you can go spend some time working with their technology teams. And that was actually quite an experience, living for 3 months in Uganda after this kind of career with ThoughtWorks. Quite a change of pace.
Yes, I can imagine. I guess we're gonna link in the show notes to this program. Maybe someone wants to find out more about it. So today we are talking about evolutionary architecture. Mm-hmm. That's actually a topic where you talk about. We already had episode 166 on living architecture, which is a similar topic. So you might find one or the other concept here again. But it's an interesting enough topic that we thought we might do another show with another perspective on it. So let me start with a slightly odd question to a CTO. Rebecca, are you an architect or are you a developer?
Well, I'm both, actually. I do think that there are perspectives of the role of architect that are distinct from the role of a developer. When you're a developer, your focus is on the specific code that you're writing, the system that you're developing, how it satisfies the business requirements, and how it satisfies the technical requirements, sometimes called the non-functional requirements, which I always think is bizarre. How can it not be functional? But it's, those things that don't directly contribute to solving the business problem. Whereas part of an architect's responsibility is to step back a little bit and set that in context. And there are many different kinds of architects. There are technical architects, security architects, data architects, software architects, enterprise architects, and all of them have a little bit different focus. But you do have to think differently about what it is that you're doing if you're looking at things in the context of, say, as an enterprise architect, you look at one particular product or software asset in the context of the entire suite of enterprise assets, and how do those things fit together?
Okay. So is an architect rather a person, or is it a role I fit in?
I consider it a role, or at least a nice umbrella for a set of activities. There are organizations that are small enough where developers and architects can easily be the same person because the scope of what you're looking at is small enough that one person can keep it all in their head. When you start to think of some of the massive enterprises that exist, one person can't keep the minutia of all of those systems as well as how everything fits together. And so then you tend to see more separation of responsibility. Yeah. But it really is a role in a set of tasks.
Yeah. When I hear you talking, I have the impression there is also kind of a layering of architecture, maybe even a hierarchy of architect, someone who has the big picture of the whole company and someone who's directly involved with the developers team?
Well, there are a layer of tasks. and you characterized it correctly, and it has more to do with the scope of what you're concerned with. The overall enterprise architect, their scope is the entire enterprise, and in fact, it might encompass the IT assets of even some of their suppliers or their customers. If you're a security architect or a data architect, your scope is much more narrow because you're focused on a particular concern.
You have a cross-cutting architectural rather than overreaching. Okay. Before we dive deeper into that, there is a famous quote from Martin Fowler saying, architecture is the stuff that's hard to change. So is evolutionary architecture the way to make the stuff that's hard to change easier to change?
Easier, but not easy. And that really is an important distinction. One of the things about architecture and the way it's been approached in the past is there's almost a speculation about how things are going to be in the future, what uses people are going to want to put my customer data to. And the architect's responsibility was almost to predict the future and try to say, okay, this is how people are going to want to use this. Therefore, I will proactively develop things that will address a future need. What evolutionary architecture is trying to get across is predicting the future is hard and getting harder. And so rather than rely on guessing right about what's going to happen in the future, you set up your systems so that it is easier to move in whatever direction the future brings.
Yeah. So when you want to set up a system to be evolved, what is the strategy for doing that? How do you know where you want to go?
Well, there are a couple of things, and this is why I distinguish between emergent and evolutionary. And this is a debate I've had with several thought workers. Neil Ford and Martin Fowler are some of them. Neil speaks a lot about emergent design, and people will often talk about architecture as an emergent architecture. And I like to focus on the evolutionary architecture because part of that is there is a sense of what is right. There is a sense of good, a fitness function. And if you think about genetic algorithms, evolutionary computation, you have a notion of a fitness function. This is my goal, and that fitness function characterizes my goal. In the case of architecture, that has to do a lot with what are the characteristics of the architecture that you're looking for. If you have a lot of personally identifiable information, credit card numbers, health information, something like that, you're going to have a much greater concern for security than if this is a sandwich ordering system. And I really am not terribly concerned if people know that I always order an egg salad sandwich. So the needs for data security are much different in that application. The different performance requirements for different kinds of systems. Do I need to worry about load? Do I need to worry about communication? Are there a lot of messages or not too many? All of those different things that we talk about from the perspective of architecture, the LEDs, as we often refer to them, how I set the dials, if you will, on my concern for those different LEDs start to give me the characteristics that I'm looking for in an architecture. These are the things that I want to maintain. And I use that fitness function as a way of evaluating the different decisions I'm making along the way. Am I keeping myself true to what it is that I'm trying to achieve? Am I moving things in the right direction? Because I have this goal. It's not just do whatever. I have a goal of satisfying these LEDs, and I'm trying to move the architecture in that direction, not get there immediately because I don't know what the path needs to look like. But as long as I know this is my goal and I need to be able to justify whatever decisions I make from the perspective of that fitness function. That's what constitutes good for my architecture.
How would a fitness function, let's say, for Twitter look, and how would the fitness function for the ThoughtWorks website look?
Well, Twitter obviously has a different volume profile. Twitter has to worry much more about burst activity. So all of a sudden something happens in the world and you've got a mass of thousands or millions of retweets. Whereas the ThoughtWorks website, you're probably going to have less focused traffic, a different load profile. You're less likely to get the enormous burst. Even when something goes seriously viral, that's not going to be the same thing as if there's some major natural disaster or a new war breaks out or some other activity where the entire world, regardless of your industry, regardless of your job, all of a sudden is taking to Twitter, that kind of load profile is not something that is going to happen on an IT company's website. And so you are looking at those different kinds of activities, different kinds of load profiles. Twitter knows a lot about who I'm connected to, who I'm following. So again, there's different kinds of information. So how they look at protecting data is going to be different than how a more content-focused website, because there's interaction that Twitter needs to know about. So their performance characteristics, their security, there are many things about how that site works that are different, and they're going to result in a different fitness function, if you will, for Twitter versus our website.
So Twitter will have, as part of the fitness function, probably stronger ability to react to suddenly higher traffic than the ThoughtWorks website has, because most of our content is probably static and can be cached.
Yes.
Okay. Let's take a little bit more a look into the terms. You said emergent design and evolutionary architecture. Can you decompose those four terms for me a little bit?
Okay. Well, let's start with design versus architecture, because that really is a continuum. When we talk about software architecture, part of what we're talking about is how am I decomposing my application into various small c components. So I'm not talking component-based architecture, but component is a nice handy word for a blob of functionality.
Probably a class and a few helper classes or something like that.
Yes. And so design is actually talking a lot about that lower level structure, but it starts to move up a continuum where you might start to say, okay, how am I going to have my inventory system correspond with my ordering system or my logistics system? Because that too is an architectural decision. Your granularity of components in that case, though, might be much larger. So there is definitely a continuum going from design into architecture. But then there are a lot of concerns that you have in architecture, like the LDs that we've talked about, your technical stack decisions, data lifecycle decisions, which are really more architectural rather than design. So you do have a continuum. There's a gray area in the middle on, would you say you're doing software design or software architecture? But really the important part of architecture is you are looking at things in a broader context. When you're talking about software design, it is much more at the code level. You're worried about how code components are behaving, what they look like.
Yeah, so architecture is more in reflected, like, for instance, UML diagram is the standard case some people fear, and while design is focused like on the line of code or on the unit of code, I would say.
That's one way of thinking about it. Yes,
Yeah.
You certainly rarely, when you're talking about architecture, are concerned with a specific line of code. But there are things there are lots of things implied by a UML diagram that aren't consistent with necessarily my view of architecture. But you do often have diagrams that if you're trying to think, for example, of how information flows through an enterprise, you might imagine that as boxes and lines flowing through to try to see how do these different systems relate to each other. And you won't see any code there, even though somewhere down in the bowels of the system, yes, there are lines of code that implement whatever that communication is.
Yeah. All right. So let's go to emergent and evolutionary.
The distinction, to some extent, is that you have a much more complex version of what constitutes your goal or goodness in an evolutionary system. There is a field, it's called emergent computation. And when you look at things like neural networks, some of the games of life and the simulation of ant colonies and such, you see what is called emergent behavior. And you have very simple interactions between these entities, and behavior emerges. When we talk about emergent design, particularly from the perspective of agile development, you're looking at, okay, I want to do the simplest thing that will solve the problem that I have now. And then as my system grows, as new requirements come on, I'm going to alter my design because I've got new requirements coming in, and that design is going to emerge. So rather than sitting back at the beginning and saying, I know exactly what my object hierarchy, for example, will look like, that object hierarchy emerges over time as these new features come in, and you decide what is the best way to implement it. And you have some very simple characterizations of what a clean design looks like. Don't repeat yourself, all of those different very simple design principles. But basically, your idea of good is not necessarily that context specific. You want a clean hierarchy, you want separation of concerns. And different kinds of code are not necessarily going to have that different a characterization of what constitutes good code. When we talk about architecture, though, as we just discussed, the performance profile of Twitter is very different than that of a content website. I have a lot more variables in terms of what constitutes my goal state, what constitutes a good architecture. Clearly, there are analogs to clean code. You want a clean architecture. You want to think about, how much chatter is between two components and such. But some of them are going to be very specific. The load profile on a system that only has to handle 100 transactions a day, how you think about your architectural decisions and what constitutes a good architecture is going to be very different than in the Twitter case. So you have more variables that are involved in that decision, and you are trying to, again, there is still this sense of you are going to move towards something, and the architecture does emerge in that sense, but it emerges towards a more specific goal.
It emerges towards a fitness function.
Yes.
So when you talk of evolutionary architecture, this means you evolve your architecture step by step in small steps. Can you contrast that with the common practice of re-architecting your system?
Re-architecting a system often happens when something major is changed. So either new technology is available that you want to take advantage of, and now I need to rethink how my system is going to satisfy my fitness function in the new context of this new technology stack. And it might be just a simple transfer, but there might be characteristics of this new technology stack that I want to take advantage of. So there are aspects of re-architecting a system that are the same. It's not so much whether or not you're re-architecting, but it is how much you decide to think about your end state at any given point in time. So one of the things that we often see, an enterprise decides we are now going to be a service-oriented enterprise, and I'm going to bring in this big tool that is going to do everything for me, and I'm going to completely re-architect my system.
Yeah. It's kind of
components.
A stop the line architecture,
Yes.
right?
Yes.
So I'm stopping the architecture, and I'm doing the re-architecture, and then I continue building something.
Yes.
Yeah.
And part of what we try to do with evolutionary architecture is, rather than have that stop the line mentality, how do I move my architecture incrementally from where I am to where I'm trying to get to?
Yeah. All right. That makes sense. So we're an Agile company, and Agile is how we want to build software, not only we, but the rest of the world as well. And architecture has kind of a bad reputation in those areas because people talk about big upfront design.
Mm-hmm. One of the interesting things, if you look at the evolution of Agile, in the beginning it was developers, and everybody said, oh, sure, it's all right for a development team to do that, but as a business analyst, I need to specify my entire problem before I can turn it over to developers and they can chunk it up how they want. And then testers, well, how on earth could I test something unless it's completely there? And we started learning over time how you do incremental testing, how you do incremental analysis. Database administrators, well, of course, I have to know what my entire data model looks like and all of my performance characteristics before we can start any kind of development. And so over time, we've been pushing the boundaries of how we look at doing a particular aspect of the software development lifecycle in an Agile way. Agile experience design. And evolutionary architecture is one way of talking about how do you think about architectural problems from the perspective of Agile. And one of the fallacies or the myths, if you will, of Agile is, okay, we come in day one and we just start writing code. You don't think about anything. Well, sometimes you do start writing code, but that doesn't mean you haven't thought about anything. It doesn't mean that there is no design. It doesn't mean that there is no architectural thinking that goes into things. But what you do is you try to address the problems as late as you can in the process. And why do you do that? Because you know more information. And so it's not that you don't do any upfront design, you don't do any upfront architecture, you just don't do it all. You focus your thinking on what problems do I need to solve now? Where is the greatest risk in my system? Okay, well, that means you might want to prioritize bringing that forward, because if you've got a major architectural risk, that is going to have a tremendous amount of influence on how you solve the problem.
So if you know that your site related to common use, you know that at some point you get hit by a few million transactions per minute.
Mm-hmm.
And that's something you want to plan before.
Yes. Well, and there are also things, very often there is some kind of reference data that might be stored in an old crusty mainframe somewhere.
Yeah.
Or maybe a bright, shiny mainframe, but it's still a very different system. And if I'm going to need to bring that data in, I'm going to have to communicate with that system. Sometimes it's very difficult communicating with those systems. And so I'm probably going to want to prioritize thinking about how it is I'm going to communicate with that external system, because it's going to be something that is more difficult, more risky, and therefore I want to bring that decision forward as long as I know enough about how it is that I'm going to have to communicate, what the communication characteristics are going to be, that I can decide what's the best approach to communicating with that external system.
So could the evolutionary architecture approach be described by I do some upfront design every sprint?
Yes.
All right. In my mind, there is a little bit the question, how would I find the right balance? Because so I understand we want to do some upfront design, mm-hmm. but we don't want to do big upfront design. It's funny, by the way, that we call it big upfront design when it's big upfront architecture.
Yes.
But that's kind of the term everyone uses. How would I balance that? What are ways to attack that problem?
Well, there's a principle that is often discussed in the concept of evolutionary architecture called the last responsible moment, and I very often get asked that question: how do I know what that last responsible moment is?
I tend to always know it when it's too late.
Yes, but that's where the value of the fitness function comes in, and definitely one of the very early things you want to do when thinking about architecture is, what are my critical architectural features? What does that fitness function look like? What are the major things that I know I'm going to have to satisfy and that are going to be the most influential in how I decide to approach the problem? And so you look at what are those problems, and then what are the decisions that have to be made, and the decisions that line up with my critical factors I want to make earlier, as long as I have a sufficient level of information. Now, it may be you have to make a particular decision that you don't have enough information to know whether it's going to be the right one, and then there are software architecture and software design patterns that will allow you to protect yourself from a potential change in that architectural feature. There is an art to this. It's not like I can give you a precise formula that this decision needs to be made 27.4 days into development. It's never going to be that precise. But as you think about how does this decision map against that fitness function, how critical is it, and that allows you to determine what's the right moment for these given decisions. When you look at something like a message queuing system, you probably know fairly early on, I'm going to need some kind of message queue for this.
Like for instance, if you do medical applications, they tend to have messages a
yes.
lot. Mm-hmm.
Yes. But you don't necessarily know, do I need to always ensure that messages are received by the receiver in exactly the same order that they were sent, or can I have a bit more flexibility around that? You might not know how persistent the messages need to be. Do I need to allow my receiver to go offline and back online and still be able to access the messages? There are all kinds of characteristics around message queues, and maybe you don't know the entire suite of functionality that is going to be involved in your message queue. You just know, I know at some point I'm going to be reading and writing messages. So start with a very simple system. Start with a very simple tool, not a much more heavyweight one that might have features that you don't need. And then when you decide, now I do need guaranteed ordering, I can't use the system that I was using before, I will pick another one. So for each one of these decisions, you need to look at how difficult is it going to be to change my mind, and how much influence does that particular decision have on how I'm going to approach the design of my application.
So when I understand it correct, last responsible monument is one of your evolutionary architecture principle, because
Correct.
you have a talk called The Principles of Evolutionary Architecture.
Yes.
What are the other principles?
Well, one of the things that we find, and when you look at thinking about an architecture, one of the things that gives you a nice amount of separation and a very clean architecture is actually to think about, how would I test this system? So architecting for testability is another one of those principles. And what happens is you end up with abstractions at the right level. It forces you into a situation where you have a nice level of separation of concerns. If you think about testability, you end up with a good architecture. And so this is another one of the principles, because what you end up with are individual parts of your ultimate system or application that are easy to move around, that are easy to swap out. It provides you a nice abstraction layer. So that is one of the principles.
So the layering of the tests you apply also gives you a good separation of concern, because if you have a good unit of test, you also have a good separation.
It's not so much the layering of the tests, but your ability to test that. And one of the things they talk about, something's wrong with your system if all of your tests are, does it do this, and this? If you can't succinctly describe what it is the test is trying to determine, you probably have too much unrelated stuff going on in there. That's true at a unit test level. It's also in many ways true even as you go further up into the acceptance and functional tests. If there's too much stuff abstractly going on that you can't succinctly describe it, maybe you haven't really thought about what it is that test is supposed to accomplish, and how that chunk of the system is going to realize that behavior.
Okay. What is another principle?
One of the things that is important to think about from an architectural perspective is how systems communicate with each other. And there's something called Pastels Law, where the implication for architecture is, I want to be as forgiving as possible for what I read. So I want to be a tolerant reader, so that if you change the message that you're sending to me for whatever reason, if it doesn't impact the things I really need from that message, I shouldn't care.
Yeah. So if I send you addresses and you only care about postcodes, you shouldn't break if I change the street format.
Exactly. Yeah. And the flip side of that is you want to be a careful writer. You don't want to put things out in a message that you aren't comfortable asserting that I'm always going to put that out there, because as soon as you put that out in a message, somebody might be relying on it. And so there's Pastels Law talks about this information exchange. We often talk about it in the context of messages, but it's the same thing if you're looking at trying to pull things out, integrating with a database, or any other event source, any kind of inbound or outbound communication. The principle it is still there. So you want to think about how that information exchange is going to work, so that I can be as tolerant to change. As long as you're not changing what I actually need from you, I shouldn't care.
Yeah. So in a way, XML schemas and relational database schemas are exactly the opposite of Pastels Law.
If you do full schema validation, yes. Yes. Now, obviously, there's a little asterisk that you always have. We don't want to be so tolerant that we provide a vector for attack surfaces for
security breaches.
Security breaches. And so you want to make sure that what you're ignoring isn't a backdoor into your system somehow. But with that caveat, you only want to be looking at the aspect of that XML message that you were specifically concerned with.
Yeah. And how does that help with evolving the architecture?
Because my part of the system can evolve as independently as possible for yours. And there's a related technique that we use on contract testing. If I have some kind of test that documents, if you will, the assumptions I am making about your system and what it's providing to me, what services or behavior I'm expecting from it, I write that into a test and I give it to you. Yeah. And then I can ignore everything you're doing until you break my test.
To be a little bit more precise, you write essentially a unit test or an integration test using a JUnit or something like that, and you integrate it both in my pipeline and in yours, and it fails if something in the interface I provide to you doesn't work anymore.
Correct.
Yeah.
Yeah. It's more like a functional test often than a unit test, but it could in fact be at a unit test level. Yeah. But I write the test and I give it to you.
So we are talking about a microservice or service-oriented situation here.
Not necessarily. We've used it in the cases of reference data coming down from mainframes, where this is how we expect to receive price information, for example, for a retailer. There very often is a separate system that is used by the marketing department when it sets prices and does promotions and such. And we expect data to come into, say, a point of sale system from that. And so we write a test which says, okay, this is what price changes are going to look like, for example. And it doesn't have to be service oriented at all. It's just, okay, I might be getting a file by FTP.
And it's still in a way a contract between two systems.
Correct.
Yeah.
Correct.
Understood. So I looked at your slide a little bit. So another principle you have is architect and develop for evolvability.
Yes. Most of the lists of abilities that you'll see, it's reliability and scalability. And the closest we really get to evolvability is often maintainability. How easy is it for someone to come in and understand the code? But thinking about evolvability is not just, is it easy to understand the code? That is a big part of it. Is the software quality such, is the software design, is the architectural design such that it is easy to come in and understand the system? But there are also some things around appropriate use of abstraction layers, because there might be some aspect of the system that is more likely to change. And so this is basically make evolvability a first class principle, if you will. And just like all of the other ilities, your need for a particular aspect of the system to be tolerant to evolution is going to be different. The laws of physics don't change very often. So if you have some aspect of your system that is doing computations on the basis of the laws of physics, you don't have to worry nearly as much about those things changing as you do, for example, how your customer might want to interact with their information. That's much more subject to change because consumer expectations are much more volatile.
Yeah.
And so just like my security characteristics or my performance characteristics might be different, my need for evolvability is different across the system. And you want that to be a first class principle. And when you're thinking about how you're going to actually implement the solution to a particular problem.
Yeah. So one way I can think of to develop for evolvability is pair programming, because you share knowledge. Is that one of them you would think of, and are there others?
That is part of it. It's not just the shared knowledge, though. It is as much when I'm writing code and we're pairing on code, each individual is bringing their particular perspective to it. And so there may be things that I've got something in my head, and you've got a different way of looking at it, and or a different vulnerability that you might be thinking about in terms of potential change points. And so we can have a conversation, and that sharing of perspectives means that we're more likely to come up with a broader perspective on where the scope of possible change comes from.
In this section, you also talk about metrics and technical depth, so how to know where you might not be so evolvable in the systems.
Yes. A lot of the software metrics that we use really address the maintainability part of evolvability, although they often also provide information about how tightly coupled different aspects of the system are. And obviously, if you have two parts of your system that have a lot of cross-references, you don't have clean separation, it's going to be difficult to change one part of that without seriously impacting the other. So there are both architectural and software metrics that address how readable some code is, how entangled different parts of the code or the systems are. And they allow, using software metrics, it allows us to both track how our system is changing over time. So if we are taking on technical debt, we're aware of it. And it also gives us guidance for how to know what part of a system that we should focus our attention on. Again, I might have something that implements computation based on the laws of physics. Well, they don't change very often. That might be messy code, but as long as the laws of physics don't change, I don't really have to worry about that code.
And if it runs fine in 20 years, I probably don't want to fix it, right?
Exactly. Yeah. Exactly.
That's the managing the debt. We actually have a good episode on technical debt up, which is episode 224. So if you want to know more about that topic, just check out the previous episode. So let's go to the final principle. And surprisingly, it's not really about software. It's about people, which is Conways Law.
Yes. We actually are hearing even more and more about Conway's Law. And informally, the way to think about Conway's Law is the resulting architecture of your system will reflect what the organization that built that system looks like. And one of the ways this manifests itself, if you have silos of IT or business in reality, and different parts of your business don't communicate well as people, chances are the integration of the systems that reflect the functions there are not going to integrate well. Because if you can't get people to communicate with each other, you don't know, well, what are the implications of the decisions that each of those systems has to make. And so you want to think about how your current communication structures, your current reporting lines, and the level of dysfunction potentially between organizations, how that might impact your system. And so the punchline really is, if you don't want your system to look like your organization, you better change your organization, because that is how the system is going to look, regardless of how hard you try. That organizational imprint will be there on your system.
So the idea is if you wanna have people separated by function, it's like business function rather than by layer, you better group the teams around the function and not by, I have a database team, I have a front-end team. All right.
Yes.
How does that help with evolvability?
Well, it's more, if you think about your organization and what are the potential changes that might occur in how your system needs to behave. If I have rigid silos and all of my customer data is locked up, managed by my customer care department, but my supply chain is locked up in my logistics department. And then all of a sudden they say, well, wait a minute, I want on my online system for someone who's a customer to be able to look at what's the status of their order. but that's locked up in the logistics system. And having silos around those things means it's probably going to be very difficult for a system that lives in the customer care part of my business to get information out of the logistics. And so by breaking down the barriers between different parts of the business, as those needs change, as those departments need to work together differently to support a different flow through my enterprise assets, we need the different parts of that organization to cooperate to allow that to happen. And so by breaking down those silos within the business, you can have different parts of the system interact that hadn't interacted before. You do get a similar thing from the technical side as well. You don't want people at the database layer or who are touching the database only making decisions that are right for the data layer, because there are other parts of the system that have to access that data. And so you want that level of cooperation amongst the various functional teams so that they understand, okay, if I make this decision about the data, this is the impact that it's going to have on the various system functions.
Yeah. Does that mean that if I'm a database expert, I lose my job?
No. Not at all. Not at all. And it's interesting. One of the things that we do try to push as Agilists is you want people to be more poly-skilled. There are certain database functions that we expect all developers to be able to do. There are certain database problems that are complex enough that you need a true database specialist. That doesn't mean that you want that true database specialist to also do all the grunge, very simple database work that 80% of the developers should be able to do just fine. There's no role for specialists, but how that specialist interacts with the other teams is going to be different.
All right. So let's reiterate on all the principles so you have them at one. So we have the last responsible moment. We have architect for testability. We have Pastels Law. We have architect and develop for evolvability. And we have finally Conways Law.
Correct.
I remember you shared some techniques for doing that as examples.
Mm-hmm.
Shall we start with database refactoring?
Yes.
We already had an episode on this, which is episode 186 on Agile database development.
Mm-hmm. So
if you want to know more, listen to that episode. But can you, in one sentence, explain what you mean by that and why it helps?
Well, as I said earlier, the early view was you have to do your entire data model upfront before you can start any kind of development. And this approach to evolutionary databases takes into account the challenges that you have if you have a database in production that now you want to change in some ways. And it looks at how do I do a refactoring on a database, just like a code refactoring is one very simple change that's easy to test and easy to maintain behavior. Well, there's a series of refactorings that you can do on databases. And the refactoring is the actual change to the database as well as what kind of migrations might I have to run to move production data from the old to the new. And then, of course, you change your code. And so you decompose all of the different changes you're making to your database into these simple refactorings that are much easier to test in isolation, and then you just compose them.
Yeah, so what it essentially means is rather than having one big SQL script to set up my database, I have a number of them.
Correct.
Like maybe 20, and they will step by step set up the database, and I can also deploy them with the rest. Okay. Yes. Then we have continuous delivery, also mentioned in show 121.
Right. So the reason continuous delivery is important for evolutionary architecture is you want to be able to safely change your system and deploy something new into production. And continuous delivery is all about making deployments boring. So you can celebrate the features and not the fact that you didn't crash the system into production. Yeah. And one aspect of evolutionary architecture is you are going to most likely be deploying more frequently and sometimes making some pretty fundamental changes to, for example, what your technology stack might look like. And continuous delivery provides the approach to making changes like that as risk-free as possible.
Yeah, and it allows you kind of evolve your fitness function faster because you get the feedback if you have the right fitness function.
Absolutely.
Earlier, yeah. So the last one we want to talk about is microservices, where we had 3 episodes by now, which is 1, 210, 213, and 216. I'm going to link all of them in the show notes, so you don't have to type them in. So microservices means I decompose my application into a bunch of small services. Why does that help with evolutionary architecture?
Because it allows you to, over time, compose those smaller services to deliver different pieces of business logic. It also allows you potentially to swap out an implementation of a particular function with a completely new implementation, because you were thinking about your architecting in a microservices architecture to have these different, again, small c components or microservices in your system. You were thinking about what those boundaries should look like, and because you're enforcing those boundaries, you can move things around, and you can replace individual parts with something different that has potentially different architectural characteristics, as an example.
So there is this notion of design for replacement rather than for reuse.
Yes.
Yeah. All right. So what is the trouble, or let me phrase it maybe differently. So given I'm in a project which runs since 3 years and we started with a big upfront design,
mm-hmm.
Is it still possible to start with evolutionary architecture?
Yes. You can gradually introduce abstraction layers that will allow you to change some of those architectural characteristics. But when you're starting from a legacy system, probably the most important of those architectural principles, since you've made a lot of the decisions already, worrying about the last responsible moment is perhaps less important, but you still want to think about, what do I have to do to make this system as evolvable as possible? You want to start disentangling different parts of your system. You want to identify where are the hotspots, where I have too much architectural dependence within a particular aspect of my system. And oh, by the way, if that's something that's changing a lot or something that is that tends to be buggy, then I'm going to want to focus my effort there, thinking about architecting for evolvability as well as for testability. Because as I said earlier, thinking about testability actually gives you those kinds of clean interface points that make it easier to evolve different parts of your system independently.
Mm-hmm. And what is the matter when I'm buying software? So is there still some room for it, or do I have to stick with everything?
It's a little more difficult when you're doing package selection, although you do want to still look at how easy is it for me to redeploy this system. Is it possible for me to incrementally configure this? Is it possible to put the critical parts of any customization in source control? So there are a lot of things, particularly around continuous delivery, that would affect my package selection. And then also thinking about how easy or difficult it is to test the resulting behavior that you're getting out of that package. When you think about a package that is only fulfilling one function out of the broader system, then you want to start to look at how easy is it to get the right kind of separation to set up the contract test, to get the communication, the messaging set up in such a way that it respects things like Pastels Law.
Okay. So I still apply the principles in the software selection, you would say.
Yes.
Yeah. All right. So when I was at university, my professors told me that good architecture means I can reuse my code everywhere.
It's a wonderful goal, but the problem is very often to have that code be reusable, you have to be able to predict how somebody is going to want to use it. And sometimes that's clear. You know, if I'm working on something quite simple, calendar functionality, well, we kind of know how people like to use calendars. They want to be able to schedule recurring appointments, and they want it to be tolerant of daylight savings time and and time zone changes and all of those kinds of things. So it's not too difficult to come up with a component that has a robust set of calendar features. Trying to speculate how your customers are going to want to personalize their information 5 years from now, how are you going to know? And so when we think about reuse from an evolutionary perspective, it's more when I see instances of reuse, I can analyze them and say, okay, what can I abstract from these different actual usage patterns, which is going to give me some guidance on how within my organization people want to use this data, and then I can make something that's reusable. But I'm making it reusable on the basis of real information rather than trying to guess what's going to happen in the future.
So the art of evolutionary architecture is to know what I know and to know what I don't know.
And try to make as few decisions as possible on the basis of things that you don't know.
Okay. So my last question. So there is no free lunch. So
Correct.
What are the costs and the downsides of evolutionary architecture?
Well, you can get things wrong. If you make a particular decision, you might, if you had thought about everything, if you had taken everything into account at the beginning, you might have done something different. You might have been able to find a more efficient architecture. You might have been able to put something in place that you could take advantage of. The problem with that is, yes, if you get it right, you can probably save yourself some time. But what's the probability that you're going to get it right? And therein lies the problem. And so there are some situations where maybe you do know more about how something's going to happen. Something that maybe corresponds to a regulatory framework. And because the way governments work, that regulatory framework is not going to change over the next 2 years or 5 years. Well, if you know what that framework looks like, you can make more decisions up front because you have less probability that thing is going to change out from under you. And that is going to be more efficient. Because if you're taking advantage of more additional information, you won't have to, potentially build abstraction layers, or you won't have to redo something because you learned something that maybe you could have known if you thought about it. So there are inefficiencies that are built into supporting this level of evolvability.
Because you might develop more layers.
Correct.
For instance, okay, and of course a microservice architecture is more work in the beginning than a monolith.
Yes, because you have a lot more to monitor. And you have to think about problems that you don't have to worry about. The permutations of failures, when you have independent microservices running in different processes versus a monolith. When I'm in a monolith, I know that either the entire thing is alive or the entire thing is dead in general. That's not true in a microservices architecture. And if my service is looking at 5 different services, well, any combination of those 5 may be unavailable. So that's all these permutations of failures that I have to think about. Whereas I don't have to worry about that if it's a monolith. If it's all in the same process, then we're either all working or all not, without anything in between.
Okay. So that's all from my side. Is there something you would like to add from your side?
Well, one of the things that we're looking at doing is trying to get more information out there about evolutionary architecture. There's the book on microservices, the book on continuous delivery, the book on evolutionary databases, but there really isn't anything out there that really talks about how to do evolutionary architecture and what it means and what some of these pitfalls are. And that's something that over the next several months I'm hoping to address. So hopefully you'll start to see some articles and some other web resources that will provide guidance in this area.
Okay, that's very nice. So is there any resources you would like to point the people to now?
There's actually very little, except I speak on evolutionary architecture and Agile and enterprise architecture a fair amount, and there are several videos out there that's available, but we'll be posting some of these things both on the ThoughtWorks website and at RebeccaParsons.com.
Yeah, I will make sure to keep the SE Radio website updated. So where can people find out more about you personally?
I do have a website, which is currently very inactive, RebeccaParsons.com. And of course, there's lots of information on the ThoughtWorks website, and my Twitter handle is @RebeccaParsons.
Okay, perfect. So thank you very much. All the information mentioned in this episode will be in the show notes. Thanks, Rebecca, for being on the show.
Thank you very much for having me.
It was a pleasure. I would like, before we close, to remind our listeners that you can comment on this episode on se-radio.net. You can also send an email to the team via team@seradio.net. We have Twitter at SE Radio, and we are on LinkedIn, Google Plus, and Facebook, all of them at Software Engineering Radio. So really let us know what you think. We like to hear your feedback. We like to hear who we should invite next. So with that, I thank you for listening, and goodbye.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio Group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.